Okay, welcome back. We are going to continue talking about our sequences in note number 2 today. Today, we're going to get a little more into the details of arithmetic and geometric sequences and some of the formulas that we can memorize and use with arithmetic and geometric sequences. In the last class, we talked all about what a sequence is, kind of how to find out if it's arithmetic or geometric or neither. And we also talked about how to come up with a rule for one of those sequences to generate terms in the sequence. Basically, a sequence can also be thought of as a function, and we've talked about that a little bit, where the domain is actually consecutive positive integers. So the domain is the inputs, remember, of a sequence or a function. So the input of a sequence is the number of the term that you're trying to find, and the output is the actual term. So if we've got a rule for a sequence such as this, then our input would be the term number and the output would be the actual term. So if we wanted to come up with the first few terms in this sequence, if I wanted to find t sub 1, that means my input is 1 because I want the first term. So I do 1 squared minus 7. And that would just be 1 minus 7, which is negative 6. If I wanted to find the second term, that's t sub 2, I'm going to input 2 into the function. And that gives us 4 minus 7, which outputs negative 3. And so on. We could find our third term. 3 squared minus 7 will give us 9. And the fourth term, 4 squared minus 7. Oops, sorry, I did that math wrong. 9 minus 7 is 2. And then 16 minus 7 will give us 9. And we could keep going, right? As long as we input the number of the term, we will actually get the output of what the term in that sequence is. And then we can start listing our terms of our sequence and so on if it kept going that way, right? Okay, then we talked about the differences between arithmetic and geometric sequences. Remember this sequence here, if we look at it, we can look at the changes each time. And this one, it looks like it's increasing by 5 every single time. So if I'm adding 5 every time, that's a common difference of 5, which means this is an arithmetic sequence because it has a common difference. We're adding to get each new term. Whereas with the next one, if I look at what's happening each time here, this time it looks like the number is getting smaller. It's also changing signs. So it's going from negative to positive, positive to negative. Kind of another sign that we're multiplying each time. But it looks like we're dividing by 2, which remember means we could also be multiplying by 1/2. But it'd have to be a negative 1/2 there. That way the sign changes every time. So this one's got a common ratio of negative 1/2, which means it's a geometric sequence. Those are our two major types, right? Okay, so we did some work with rules of a sequence. If we were given a rule, we could come up with all the different terms. We can also do it kind of the other way, where if we've got all the terms, we want to come up with a rule for any term of an arithmetic sequence. So let's kind of think through how we develop this formula. If we look at this sequence here that we've got, this is the same one that we had up here, right? So we know it's an arithmetic. It's increasing by 5 each time, right? So our common difference there is 5. Okay, so to generate the terms, to get our first term is negative 20. That's given to us. We know where to start, right? If I wanted to get my second term, well, I'm going to start with my first term, and then I have to add the common difference. So I would add 5. And that would give us our second term, which is negative 15, right? If I wanted the third term, instead of taking that second term, I can still start with the first term because we always usually know the first term of a sequence. And instead of adding 5 once, I'm going to add 5 twice. So that'd be the same as adding 5 times 2, right? So it's negative 20 plus 10, that gives us negative 10. We could do it again, right? If we want to get our fourth term, we would do negative 20 plus 5 times 3. And that would give us negative 20 plus 15, which is negative 5. If I wanted to jump way ahead, let's say I wanted to get the 100th term in this sequence, right? I can still start with that first term, and I still have to add the common difference. It's just about how many times do I have to add it? Well, to get the second term, I added 5 once. To get the third term, I added 5 twice. To get the fourth term, we added 5 3 times. See the pattern there? So if I want the 100th term, I need to add 5 99 times, right? And that would generate our 100th term. So it seems like to get a formula for whatever term we want in the sequence, and remember, that's the nth term is what we call that. So if I want the nth term in an arithmetic sequence, every time I started with the first term, and then we added that common difference, which is d, times, well, the 2, 3, and 99, that number is 1 less than the number of the term that we want. So I take n, the number of the term we want, and we want to subtract 1, right? That's how we can get any term in an arithmetic sequence. And if we look at this next page here, there it is, nice and big in a box for you. That's that same formula we just talked about. The only difference here is sometimes you'll see it where the n minus 1 and the d are switched places. You can still write it as a sub n is the first term plus, if you want to put the common difference in front, times n minus 1. Those are the same thing. You could do either one of those two formulas, right? So that formula will generate any term we want out of an arithmetic sequence. It can also create a rule for any arithmetic sequence. So in our first example here, we've got the sequence 5, 8, 11, 14. First thing I want to do is find out what kind of sequence it is. So to get from 5 to 8, that looks like we've got to add 3. From 8 to 11, add 3. 11 to 14, we've got to add 3. So definitely an arithmetic sequence there because we're adding the same amount every single time. We've got a first term of 5, and then our common difference would be 3, right? So if we take our formula, we said the nth term would equal the first term plus the common difference times n minus 1, right? So now we can plug in the things we know. We know the first term and we know the common difference. So one way to write our formula was we could say that a sub n equals the first term, which is 5, plus 3 times n minus 1, right? That would be one way to write the rule. Now we could also take that rule and simplify it. And if I take the a sub n, 5 plus 3 times n minus 1, if I distribute in the 3, we'll get 5 plus 3n minus 3. So that would give us the nth term. If I add my like terms there, I'd get 3n. 5 minus 3 is plus 2. So I could also write it that way, right? These two guys here, those are equivalent, just two different ways to write that rule. Whether you want to write it kind of more like the formula over here, or if you want to simplify it and leave it that way, you'll see that done both ways. Okay, so then if I wanted to find the 17th term, right, t sub 17, that means I want the 17th term for this arithmetic sequence. So I'll notice that the sequence is the same as what we just did in example 1. So we've got our rule. We can do it either way, right? We can use this first rule that we said, the a sub n equals 5 plus 3 times n minus 1. Or if you had already simplified the rule to a sub n equals 3n plus 2. Whichever way you do it, you're going to end up with the same answer. So if we use the purple side over here, I'm looking for the 17th term, right? Oh, and we use t instead of n in this one. So if you want to write it as a t so it matches, you'll see that letter kind of interchanged quite a bit. A is popular, t is popular. You'll see different letters used. So this one, if we want the 17th term, we're just going to plug in 17 for n. So to get our t sub 17, we'll do 5 plus 3 times 17 minus 1. That's 5 plus 3 times 16, which is 5 plus 48, which will give us the 17th term is 53. And if I use my green formula over here, again, same idea, the 17th term is 3 times 17 plus 2. Our 3 times 17 is 51 plus 2, which again still gives us 53. So it's totally up to you which way, if you want to use the original rule or if you want to simplify it. I would take a correct answer either way. Now, sometimes you will see a question that says, like, give the simplified formula for the nth term of a sequence. If it asks for the simplified rule, then you want to use the green one where you actually simplify it. But if it just asks you to find a certain term, you can just go straight to the purple one where it's not simplified, whichever is easier for you. Okay, another example of where we can use this. This time, it's asking us for the 100th term, right? So we're looking for the 100th term of an arithmetic sequence. It's already telling us that it's arithmetic. So as soon as it tells me that I want the 100th term of an arithmetic sequence, automatically I now know that I'm going to use this formula. So I'm going to go ahead and write it down. I want the 100th term, which means I'm going to take the first term of the sequence and I'm going to add my common difference times 100 minus 1. Right? I already know that's the formula I'm going to use, so I'm going to go ahead and write that down. Okay, then the other information that we have is that the third term is 8 and the fourth term is 6. So notice this time we're not given the first term, so it's a little bit different. So I like to kind of write out my terms. This goes third and fourth, right? So I've got the first term, second term, third term, fourth term. So we know that the third term is 8 and the fourth term is 6. This is a sub 3. This is a sub 4, right? So I don't know what my first term is, but I need the first term in order to use that formula. The other thing we need is the common difference. Well, we do know the third term and the fourth term, so if we look at the difference between those, because we already know it's arithmetic, we can just look at what did I have to add to 8 to get to 6, right? So to get from 8 to 6, I'd have to add -2 or subtract 2. So that means that our common difference has to be -2. So we've got that part that we can plug in. Well, if we know that the common difference is -2, we can just work our way backwards to get back to the first term, right? So if we take 8, and we've got to do the opposite because we're going backwards. So normally we would subtract 2 to go this direction, right? So the next term over here, 6 minus 2 would be 4. Now we got to go backwards. So we're going to add 2. So that means our a sub 2 would have to be a 10, which means our a sub 1 is going to be 12. Right? So now we've got our first term, we've got our common difference. So now we can go back over here and plug them in. So to get the 100th term, I'm going to take my first term, which we just figured out is 12. We're going to add the common difference, which is -2, times 100 minus 1, which is 99. Okay. So then we get 12. -2 times -2 times 99 would be -198. And then that means that our 100th term is 12 minus 198, which is -186. Right? And if you kind of think about it in respect to that sequence over there, it makes sense, right? We started at 12. Our numbers are getting smaller because we're subtracting 2 every time. So if I keep going and I keep subtracting 2, our number should get to the negatives, and it should get pretty big negative because we're going all the way to the 100th term. So a little bit of problem solving in that one, but nothing too complicated. Okay, move up. Come on. There we go. Okay. I think we kind of through the same process with a geometric sequence this time. So now we've got our geometric sequence. Again, this is the same one we talked about on the first page of our notes today. So we already figured out that this was a geometric, and we said to get from -20 to +10, we'd have to multiply by -1/2, right? So that means that our common ratio is -1/2. Okay, so again, if we kind of think through getting a whole bunch of terms here, we already know that our first term is -20. To get our second term, we're going to take that first term, and because it's geometric this time, right, we're going to multiply by our common ratio, which is -1/2. And that gets us that positive 10. To get our third term, if we start with that first term again, we want to multiply by -1/2, but now this time I need to get to the third term, so I'd have to multiply by -1/2 2 times. To do repeated multiplication, that's like raising a number to an exponent. So if I need to multiply by 1/2 and then multiply by 1/2 again, that would be just like multiplying by -1/2 squared, right? And if I wanted the fourth term, I would do -20. And this time I got to multiply by -1/2 3 times. And again, if we kind of jump ahead a ways, if I wanted the 100th term, I would take my first term, and then I got to multiply by -1/2. And again, look at that relationship here. If I want the second term, I multiply once. If I want the third time, I multiply twice. Fourth term, I multiply 3 times. So if I want the 100th term, I'm going to multiply 99 times, and that would give us our 100th term. Okay, so kind of using that information, we can make a general equation here. And we can say that if I want the nth term of a geometric sequence, we're going to start with the first term. We're going to multiply by the common ratio, but then we're going to raise that to an exponent that's 1 less than the term that we want. So n minus 1. So there is our rule for generating terms of a geometric sequence. And again, right underneath here, you've got it nicely laid out. So you can see it. There's your form or your formula for generating terms of a geometric sequence. Okay, so let's try one of these out. If we want to come up with a formula for the nth term of this sequence, again, we want to decide, is it arithmetic or is it geometric? That's always your first step. So to get from 3 to -12, well, if I was thinking about adding, I'd have to subtract I'd have to subtract 9. But if I do -12 minus 9, I'm not going to get positive 48. So it's not arithmetic. Here, instead, I can multiply by -4, and then -12 times -4 would give me positive 48. So it's definitely a geometric sequence, and our common ratio would be -4. That's what we're multiplying by each time. So to get our rule or our formula for the nth term, we just follow our formula that's up here. So to get our nth term, I want to take the first term, which is 3, and we're going to multiply by the common ratio, which is -4, and then I'm going to raise that to the n minus 1 power. Now ask yourself here real quickly, would I be allowed to just say that that's -12 to the n minus 1? And I hope you're yelling at me and saying, no, Miss Mac, you can't do that because you have to do exponents before you can multiply. So be careful there. Watch your order of operations. I can't simplify that rule. That's as easy as it gets. Okay, so when we use the rule, we got to do the exponent first, then multiply by 3. Follow PEMDAS. Okay, so let's kind of use our rule we just came up with, and we want to find T6 or A6, whichever letter you use, that's totally fine. Same sequence we had in the previous problem. So we gave our rule as A sub n equals 3, -4 to the n minus 1. So we're going to plug in the stuff that we know. So if I want the 6th term, and if you want to use t here to be consistent, we can. So I want the 6th term. That means I'm going to do 3 times -4 to the 6 minus 1, right? Which means we would want 3 times -4 to the 5th power. Use your calculator here. Do your exponent first. So do -4 to the 5th power. That's going to give you a negative number. And then that negative number times 3 will give us our 6th term, which is -3,000. 3,072. Okay, type that. Take like a second here. If you have to pause the video for a minute, type this into your calculator. Make sure you get this same answer. You want to make sure you know how to use your calculator on these problems. You can actually type in your calculator, if you've got the ability to use parentheses, you can type in 3 parentheses negative 4, and then some of you have to push that little caret button. Some of you have to push the X to the Y button, whatever button it is to get your higher exponents, and then your 5, right? Some of you, if you've got one of the simpler scientific calculators, you're going to have to do negative 4. Make sure you use your parentheses to the 5th power. And then after you do and you get that answer, whatever it is, then you can multiply it by 3 to get your final answer. Make sure you can do that correctly in your calculator if you know how to get those numbers. Okay, let's try another one here. Okay, so our next one, we want to find the 23rd term of an arithmetic sequence, right? So again, right there, it tells me what formula I'm going to use, right? I want the 23rd term in an arithmetic sequence. So I'm going to just start by writing that formula down. So I want A23, and our arithmetic says I start with the first term, and then we add the common difference times n minus 1, so that'll be 23 minus 1. Or if you want to just write 22 there, that's fine, however you want to write it. Okay, and then this time we're given that the second term is 4 and the 5th term is 22, right? So this time we're going up to 5 terms. I'm going to write out my terms over here. I've got 1, 2, 3, 4, 5. We know the second term is 4 and our 5th term is 22. Okay, so this time we don't have our 2 terms right next to each other. So it's a little bit harder to figure out what that common difference is because we don't have 2 terms right next to each other, right? But we do have some information here. We know what the second term is. This is A2. And we know what this term is. We know that it's A5, right? Okay, so there's 2 things we need to find out. We need to find out the first term. We need to find the common difference. If we've got 2 variables to figure out, that means we need 2 equations, right? Well, I can make an equation for A2 and I can make an equation for A5. So that's what we're going to do. We can say that our second term would equal our first term. Oops, and we know our second, well, let's write it this way. So our second term would equal our first term plus the common difference times, and if we're doing the second term, that'd be 2 minus 1, right? Well, we know what the second term is. The second term is 4. So 4 equals our first term plus our common difference. 2 minus 1 is just 1, right? So that would just be 1, or d times 1, which is just d. So there's one equation we can use. Then we also know our 5th term. So I could say A5 is the first term plus d times 5 minus 1. Again, we know the 5th term, that's 22. The first term plus our common difference. 5 minus 1 is 4, so it'll be d times 4, or 4d. Okay, so now that we've got those 2 equations, here's a system, right? We've got a system of 2 equations. You can use substitution or elimination, whichever one you prefer to solve. This one is kind of nicely set up for substitution if you want to do that. So I'm going to solve this first one for A1. So I'm going to subtract D on both sides. And I would get A1 equals 4 minus D. If you want to do this with elimination, you are more than welcome to. So I'm going to take that and I'm going to plug it in for that A1. So I get 22 equals 4 minus D plus 4D. So all I did was replace the A1 with 4 minus D. Now only D is in that equation. I can solve it. So 22 equals, we've got 4 minus D plus 4D. So the negative D and the positive 4D. That would make 4 plus 3D. We then subtract 4 over to the other side. That gives us 18 equals 3D. And then divide both sides by 3, we get D equals 6. And hey, now we know what our common difference is, right? We've got a common difference of 6. So now you could go a couple different ways with this. You can take D and you could take that and plug it back in here, right? And I could say that 4 equals our first term plus our common difference, which is 6. So then if I subtract 6, that makes my first term -2. Or you could just take the common difference up to where we first said this and then just subtract your 6, and that'll give you your first term. Whichever way you think about it, it doesn't really matter. But now I've got the first term and I've got my common difference. So now we can come back to our original problem up here. We wanted to find the 23rd term. So to find a 23, we plug in our first term, which we now know is -2, plus our common difference, which was 6, times 23 minus 1 is 22. Okay. Oh no, sharp my pen, sorry. Okay, so then that will give us -2. Oops. Sorry, lost my spot. Plus 132. And then if we add those, we get a 23 equals 130. That's what we were after the whole time. Okay, so that one's a little bit more complicated. We had to go through a few more steps to figure out the different parts of the problem. So we had to figure out our first term and our common difference. There are other ways to figure out that common difference. Some people can just look at this spread here and figure it out, and that's totally fine with me. Just make sure you're showing me how you figured something out, especially when we take our kind of take-home quizzes throughout this unit. If you're going to do this a simpler way because you just use logic, that's totally fine. Show me the math, even if it's that simple subtraction or addition problem. Write down what you're doing so I can understand what you're trying, okay? All right, we've got one more problem on here to try. And this time we're looking for the 8th term of a geometric sequence. So again, I'm going to go ahead and fill in that first basic equation or basic formula. If it's geometric, I want the 8th term. If it's geometric, I want the first term times the common ratio raised to the n-1 power. So whatever our first term is, times our common ratio to the n-1. Okay. Okay, and this time we are given the second term is 22, the fourth term is 88. Okay, so again, if you want to kind of fill those in just to see what it looks like, second term is 22, fourth term is 88. So again, we have this kind of spread here where it's not as easy to figure out what that common ratio is, but we can do the same thing we did in the last problem where we set up a system. We're just using a different formula. We're using geometric instead of arithmetic. So we've got our A2, we've got our A4. So we'll set up our two equations. Okay, so let's do A2 would equal our first term, which we don't know, times our common ratio, which we don't know, and then that would be to the 2 minus 1 power. Well, we know our second term, that's 22. So then A1, and then 2 minus 1 is just 1. So that'd be A1 times R, would be our first equation. All right, then for A4, we'd want our first term times common ratio, and then to the 4 minus 1 power. Our fourth term is 88. And then our first term times, this would be the common ratio to the third. 4 minus 1 is 3, right? So now we've got, again, two equations that we can use into a system here. Now, I will say with geometric, you want to do substitution. Elimination can't happen here because we've got multiplying going on with our two variables, so you want to use substitution. Much, much easier. It's also much easier if you solve the one that has a smaller exponent for one variable and then plug that in. And you want to solve it for a 1. So I'm going to take my first equation here because it has a smaller exponent on the r, and I'm going to solve for a1. So I'm going to divide by r and divide by r. So that would give us the first term equals 22 over r. So now I'm going to take that and I'm going to plug it into this equation for a sub 1. Okay, so we take 88. Let's give myself some more room here. 88 would equal, but for a1, I'm going to substitute in that 22 over r, and then I'm going to multiply that by r cubed. Okay, so then when we plug it in that way, this nice little thing happens where that r crosses out, and then this would just become r squared if we simplify that, right? So that means now I've got 88 equals 22r squared. So I'm going to divide both sides by 22. 88 divided by 22 is 4. And then we're just left with r squared over here. And then r squared, that means we want to take the square root of each side. So we get r equals, the square root of 4 is 2, but we're solving here, so don't forget, you need your plus or minus, right? So that means our common ratio, actually there's two possibilities. Our common ratio could be positive 2, or the common ratio could be negative 2. And there's nothing wrong with our common ratio being positive or negative, so we actually have two possibilities here, right? Okay, so if our common ratio, and we'll kind of go through our two scenarios here. If the common ratio is positive 2, let's do that one first, right? So if we go with our first option, where our common ratio is positive 2. Okay, so I'm going to kind of just go back to the sequence up here. If our common ratio was positive 2, that means to get back to the first term, we would divide by 2, right? So if our common ratio is 2, then that would mean that our first term would have to be positive 11. If our common ratio is negative 2, then that means we would take 22 and divide by negative 2. Then we would get a first term of negative 11. Right? So we have these two possibilities. Okay, so using both possibilities, we're going to find our eighth term. That's what we originally wanted to do. Okay, so if we go with our first possibility, where r is positive 2, to get our eighth term, we would do positive 11 times our common ratio, which was, or in this case, we're doing positive 2, and then to the 8 minus 1, right? So 11 times 2 to the 7th power. And if we do 2 to the 7th in the calculator and then multiply that by 11, 2 to the 7th, that's going to give us a positive result. And then a positive times a positive makes our eighth term become 1,408. So there's our answer with that possibility. Okay, if we do it with our other possibility where r is negative 2, then our eighth term, take our first, which is in this case negative 11, and we multiply by our common ratio, which in this case is negative 2 to the 8 minus 1. Now we're doing negative 11 times negative 2 to the 7th power. Now if I do a negative power to an odd exponent, I'm still going to end up with a negative result there. So then if that's negative, I'm going to do a negative times a negative 11, which will again give us a positive 1,408. So in this case, even though there were two possibilities for the r value, we end up getting the exact same eighth term. So it doesn't matter in this case, because they were asking for the eighth term, it doesn't matter whether the r was positive or negative. Now it might have been different if they were asking for the ninth term, because then this exponent would have been a positive number, an odd or an even number, which could change the signs up a little bit. So it just depends. You've got to try both scenarios. Sometimes you're going to have just one possibility. Other times you might find out that there are actually two possibilities for the eighth term, and that's totally fine. Okay, so be careful with those. All right, so those are a little bit tougher with the systems. The arithmetic is not too bad. The geometric's a little bit harder. The thing that will make it a little bit easier for everybody is make sure when you're doing the solving over here with the systems, you do it in the way I told you. Use substitution and then solve the one that has the smaller exponent and solve it for a1. That will help is kind of the algebra part of that. Okay. All right, your homework 2 is posted. Thank you to those of you who have already posted up your and submitted your homework number 1. I'm seeing lots of those get put in there. I will give feedback as I can, and I will be available to some of you tomorrow, to some of you the next day, depending on if we have class or not, for questions if you have any homework questions. So please make sure you're sending me a message in Google Chat if there's anything at all that you should need.